Hello and welcome to Technical Utkranti. And today we are going to see the 11th question of our array in the data structure and algorithm series. So let's get started. So the question is find repeat and duplicate number. In an array of length n, there could be elements between 1 to n, out of which exactly one is repeated or duplicate and exactly one number is missing. We need to find what is the missing number and what is the duplicate number. So for example, in this array, we can see the duplicate number is 3 and the missing number is 4. So how are we going to do that? So the first approach, which is quite simple, is the frequency map approach. Herein, as we have already seen in the previous questions, we just set the corresponding index to 1 or we increment it by 1 based on the elements found in the array, right? So 3 means third index, 1 means the first index, 2 means second index, and 3 means this index being set to 2. So if an index goes to value 2, this means that the corresponding number, which means that 3 is the index of this number, this is repeated and we find the duplicate. We do this incrementing the index exercise for the entire array, and the index which remains set to 0, the corresponding number was not found in this array. So that makes us the answer for the missing number, right? In this, the time complexity in this approach is O of n, because we have to iterate on the entire array. And the space complexity is also O of n because we have to make one more array of the same size approach. So in the second approach, this is more mathematical, but it is very easy. So what we do is we sum the first n elements because the numbers could be between 1 to n, right? And then we sum up array elements. Now when you subtract this from this, what you get is missing minus extra. Similarly, when we subtract the sum of squares of these two things, then we get missing square minus extra square. We have two equations and two variables. Just solve them and get the answer. Here, the space complexity is O of 1 only. Here it is wrong. So the space complexity is O of 1 for this approach and the time complexity is O of n. Look at the implementation. It is simple only. The sum of 1 to n would be n plus 1 by 2, and the sum of squares would be n plus 1, 2n plus 1 by 6, and the sum of array could be found by this, and a square of sum could be found by this piece of code. Then I would just subtract the sum to get missing minus duplicate and subtract the squares to get the missing square minus duplicate square. I do the calculation and find the duplicate and missing. So for example, here as you can see 3 is missing and 2 is duplicated, so we should get 2 comma 3. So let's see. Yes, right. In this approach, if the n is very large, then the multiplication and all this calculation might require different data types. So that, I mean, the limit on n should be known in order to have this approach working fine, right? So let's look at the final approach for this question. So final approach is the XOR based approach, XOR, bitwise XOR. So we take this example. So n remains 5, but the input array is 1, 2, 2, 4, 5, this one. Okay. So when we XOR these elements, so XORing is done between 1 to n and then the array having elements 1 to n. So what we get is like 1 cancels out 1, 2 cancels out 2, 3 remains because it is not there for getting cancelled, 4 cancels out 4, 5 cancels out 5. So we get 2 XOR 3. Basically, the output of this particular operation would be the XOR of the missing and the duplicate elements. Okay, so we know that the resultant bit would be 1 only if the corresponding bits on the two numbers in this operation are opposite according to this truth table for XOR. So we find the least significant bit which is set in the above result. Okay, so in this case we get 1, I mean 2 or 3 would be 1, and the bit index, corresponding bit index, comes out to be 0. 0 is uh, the first bit it set would be set in 1, so bit set index we get 0, right? Okay, now what we do, the second step is now to divide 1 2 3 4 5, which is 1 to n, and the array based on this bit being set or not set. Okay, so for example, in 1 2 3 4 5, we have 1 3 and 5 in which the first bit is set, and 2 and 4 in which it is not set. Okay, and in the given array in 1 and 5 the bit is set, and 2 to 4 it is not set. When we divide the given input array based on that bit being set or not set, then the missing part or duplicate part gets divided out. All right, so duplicate part, duplicate element that are there, they get comes up together. All right, and once the duplicate element would automatically be there in this division, so here it becomes 3 times, right? And over here the missing element will not be there, and in the original this thing missing element would be there. So this again like gets separated out in the XOR operation. Okay, so let's look at the implementation. So this is the implementation, and what we are doing is, firstly I am iterating on the given input array and XORing each element up. Then I am iterating from 1 to n and XORing it up again. So I have XORed everything. Now I am finding the least significant bit that is set. So I am storing it as bit set. Then I am keeping two variables, XORed set and XORed not set. Okay, so these would act as buckets. So what I am doing is I am iterating over 1 to n uh, range, and if in that if in this particular range any element, this particular bit which we have found over here is set, then I am XORing it up, and if it is not set, I am like XORing it in this particular bucket. Okay, so if you want to see the implementation of calculating the bit set, it is over here. Similarly, I am doing it for the array also. Okay, and once all the XORing operation is done, we just see that if we don't we have found two numbers, but we don't know whether which of them is duplicate or which of them is missing. So we see that if the number is there in nums, I mean the array, then it is duplicate and the other one is missing, or vice versa, right? So that is the implementation. And so over here, so I'll just take some other input, let's say 1 2 2 and 4. So here 2 is duplicated and 5 is missing. Let's see. Yes, we get the answer. So as you can see, we did not have to create any other array in the implementation, and therefore the time complexity is O of n and space complexity is O of 1 for this. So what is the lesson learned in this? So we just see that Zorin cancels out the same numbers, and yeah, that's it.